correlation, which means that maybe you're familiar with another word that is autocorrelation, that if you focus on the error term, right, you focus on the error term, and the previous error terms are sort of connected with today's error term, and today's error term will influence tomorrow's error term. So there's a whole series of that error term are correlated, so we call that serial correlation. So the series error term are correlated. So as the name suggests, pretty simple, right? So how to do that? How to find out if there is a serial correlation? So let me just draw you a graph. So say if you look at the error term specifically, so if the serial correlation here, it might be something like this. This is a very significant positive serial correlation. So the error term just go up all the time. Or if you are talking about the negative serial correlation, it might be something like this. All right, so positive, negative, pretty simple. And if there is no serial correlation, which is good, so just a random here, that's just pretty good, right? So, but I don't think the exam will just give you this quiz this way, because as you know, the CFA are really reluctant to give you a graph. Okay, so maybe they just give you some text to the written on words. Okay, so you need to do that, of course. And we have a more specific scientific method, which is called the DW test. Okay, I think that is really important tool that we need to master in order to pass the CFA exam. So we pretty much just give you hypothesis, give you a null hypothesis, that is there no serial correlation, and to check whether there are serial correlations. Okay, so I don't think you need to understand this null hypothesis and alternative hypothesis, but rather you just need to memorize the DW test is equal to the DW value is equal to 2, multiply that by 1 minus the 1 minus r, right? Multiply that by 1 minus r. And r is equal to, is kind of just a correlation here. So let's just see. If you just grab the DW value as a line here, you know, if the correlation do have a certain range is 1, minus 1 to positive 1. Okay, so you kind of just input all this extreme value in order to get the range of the DW value. Okay, so if you got the minus 1 here, all that equals 2. 2 by 2 will give you 4. Okay, 2 multiplied by 2 give you 4. If you got 1 is 0, so it's 0, 0, 4. That's the range we got of the positive of the DW test. And how to do that? What is the positive serial correlation? What is the negative serial correlation? You can sort of just give you specific number, and you just plot that on your graph, right? So if there is no serial correlation, r equals to 0. So you got 2 here. So that is the point where there is absolutely no serial correlation, because once you got 2, the r will be 0, which means the correlation will be 0. So there will be no serial correlation, right? So let's just put another number. So if you got a minus 1 here, that is definitely negative serial correlation, right? But once you got that, you got 2, and 2 by 2, we got 4 here. So at this sign, at this side, will be the negative serial correlation. And you can use the same method to get the conclusion. That is, at the left side, we will get the positive serial correlation. Okay, so 0 to 4. That's the graph we are talking about. And that's pretty much all. And if you are going to look at the graph, for example, if the quizzes give you a graph to let you just check the specific low point and upper point, you can sort of just choose. For example, if you got the let's see, if you got the degree of freedom, I do think you might got the degree of freedom here. So so if you got the, let me just plot that here, low point and high upper point, upper bound, and at the other side we got the 4 minus the upper point and 4 minus the lower point, okay, because it's just like the mirror side of the image. So you just use 4 to subtract all that. For example, if it's here, so if it's here, you use the sorry, this is just use that, the low and the upper, right? So it's much like the mirror image. So you just use 4 to subtract the line here, and you got the mirror side of the image. Okay, so you pretty much got the whole idea of what is the graph about, and so you might need to check the 2 points here, lower point and upper point. So you might get a graph that give you a degree of freedom here. So degree of freedom, maybe a lot of degree of freedom, maybe a random number. Let me just put an A here, right? And you use degree of freedom. You use that. I don't know. Just use the information that the test question gives you. Okay, and you can sort of get the point, the lower point and upper point, right? So once you got the lower point and the upper point, and to help you understand, you can just draw a graph at the paper, right? You draw a graph, you put the 0 to 4 here, and once you check the lower point and upper point, you just graph the lower point, upper point, and 4 minus the lower point and upper point to get the mirror side of the thing, right? And you just draw graph. Okay, so this is definitely positive. This is a positive correlation. This is definitely negative correlation, and this side is definitely no zero correlation. Between all that, of course, you will get the not conclusive, because you know, it's, some attribute might give you the idea to the positive zero correlation. Some idea may give you that it's known zero correlation. So you can't get a very conclusive answer. So at the between, you get the not conclusive answer, right? And okay, I got the graph. Let me just give you the graph. Okay, this is just n, different number. Maybe you got 500 of the data, and 501 and 502, and we got all sort of D1, the low and the upper, right? So just choose the one that you think is the most suitable. For example, if it's 1.27, 1.8, maybe 5.8, I don't know, just a random number I'm making up. Okay, so just get the number and put that into a graph, and you look at the graph, you can easily get the answer of whether there is a positive zero correlation, negative zero correlation, not conclusive, or no zero correlation, right?